In this video, we are going to show some examples of multiplying and dividing fractions, and then providing some explanation as to why we use the methods we do. Okay, so let's look at a fraction 2/3, and let's multiply this by a whole number. Let's multiply by 5. Okay, so when we multiply in fractions, we don't need to worry about different numerators and different denominators. So if we multiply 2/3 by 5, we get 10/3. Now, the numerator here tells us the magnitude, and the top part tells us how many. Now, we can write every integer, that is every whole number, as a fraction by just putting 1 as the denominator. So this is saying that we have 10/3, and we can simplify that by saying, well, there's 3 3's in 10, and there's 1 left over. Now let's have a look at another example. Let's have a look at 2/3 multiplied by 4/5. Well, we can just multiply straight out. 2 times 4 all over 3 times 5. 2 4s are 8, 3 times 5 is 15, and we can't simplify that fraction any further. Let's have a look at 2 more examples. Let's do 2/3 times 7/8 and 3/5 times 4/11. Pause the video and have a go at doing these. Okay, hopefully you've done that now. So that is 2 times 7 over 3 times 8. 2 7s are 14 all over 24. We can simplify that by dividing by the highest common factor. The highest common factor there is 2. 14 divided by 2 is 7. 24 divided by 2 is 12. Okay, 3 times 4 multiplied by 5 times 11. 3 4s are 12. 5 times 11 is 55. And we can't simplify there. Okay, so let's just recap that when we multiply fractions, we don't need to consider whether the denominators are different. We can just multiply straight across. I'm going to do one more final example. Okay, so if you've got A over B multiplied by C over D, we can just multiply straight across. A times C over B multiplied by D to give AC all over BD. And I would like you to copy that down. And then use that rule to do this example. Okay, so hopefully you've paused the video and you've done that. So we just do 2 times 4 all over 3 times 5. 2 4s are 8. 3 times 5 is 15. We can't simplify that any further. Okay, dividing fractions is a little bit different. Now, the explanation for dividing fractions I'm going to do at the end of the video. If we have a fraction 2/5 divided by a third, what we do is we do 2/5, we change the division sign into multiplication, and we invert the second fraction. Invert means turn upside down. Means turn we simply reverse the numerator and denominator. So 2 times 3 is 6 over 5. That gives 1 and 1/5. A very simple explanation for why we invert is that multiplication and division are inverse operations. So what we are really asking there is 2/5 what multiplied by a third gives 2 over 5. And then simply we can do the inverse operation. So we can unpack 2/5 and say, well, let's do the reverse to get 6 over 5, which is 1 and 1/5. So if we multiply a third by 1 and 1/5, we should get 2/5. So let's do that then. 2 over 5 times 6 over 5. 2 6s are 12. 5 times 5 is 25. We can simplify by dividing by 5. So we're going to get 2. 25 divided by 5 is 5. Okay. There's a more detailed explanation at the end of this video, but that will suffice for now. Okay, so let's do the method in algebra for you to write down. Okay, so if we have A over B divided by C over D, that is the same as doing A over B multiplied by D over C, and that is equal to AD over BC. And you can copy that down into your books. Okay, so let's do 3 examples. 1, 2, 3. And I'd like you to pause the video to do these examples. Okay, so pause the videos and have a go at doing these questions. Okay, so hopefully you've done that now. So we've got 2/3. We multiply 7 over 4. 2 7s are 14. 3 4s are 12. There's 1 12 in 14. And there's 2 left over. And that simplifies to 1 and 1/6. So we've got 3/7 multiplied by 10 over 3. So we can perform a simplification here. We could cancel the 3's, or we could just multiply straight out. So I'll cancel the 3's first. So when we cancel them, we are dividing. So we've got 1 times 10 is 10, and 1 times 7 is 7. There's 1 7 in 10, and there's 3 left over. We could also multiply straight out to get 3 over 7 multiplied by 10 over 3. 3 times 10 is 30. 3 times 7 is 21. There is 1 21 in 30. And there is 9 left over. And 9 over 21 we can divide by 3. To get 3 over 7. Okay, so it looks like we made a little mistake here. 1 times 10 is 10, 1 times 7 is 7. Okay, so this should be 7. It's a terrible mistake here. That should be 7. Okay, so let's have a go at doing this one. We've got 7 over 11 multiplied by 13 over 2. Can't perform any simplifications here. 7 times 13 is 7 times 10 is 70. 3 times 7 is 21. 70, 80, 91. All over 2 times 11 is 22. Now we need to ask ourselves, how many 22s are in 91? There are 4 22s in 91. And now we need to multiply 22 by 4 to get 88. And we have 3 left over. So we do 3 over 22. Okay, so copy this down. And if you need to pause the video, pause the video. Then have a go at doing these examples. Pause the video if necessary. Okay, so hopefully you've done these. So mark your work. The answers are here. So let's have a look at another explanation as to why we flip the second fraction and multiply. Okay, now let's consider the fraction 3/4 divided by 2/5. Now that is the same as doing 3/4 divided by 2/5. Okay, now let's multiply this fraction by 1. If we multiply that fraction by 1, it stays the same. All we've done here is we've written this division in a slightly different way. So let's write it down again. Now we're going to multiply by 1 again, but we're going to write that 1 in a slightly different way. We're going to write it in a slightly different way. We're going to write it as 5 over 2, all divided by 5 over 2. Now, if we divide that out, we're going to get 1. So let's see what we have now. We have 3/4 times 5 over 2. 2/5 times 5 over 2. Okay, so we can cancel out here because multiplying by 2 and dividing by 2 is the same thing. Dividing by 5 and multiplying by 5 is the same thing. So we just get 1. And there we are left with 3 over 4 multiplied by 5 over 2. And as you can see, the division has changed to multiplication, and we've inverted the second fraction. 3 times 5 is 15, 2 times 4 is 8. We're going to get 1 over 7 over 8. Okay, I hope you enjoyed that little proof. Now let's extend our proof using algebra. Now, see if you can pause the video and write your proof using algebra. This is an extension question and it's not going to come up in the exam. Okay, so we needed to prove this. A over B divided by C over D is equal to A over B multiplied by D over C, which is AD over BC. How on earth are we going to do that? Well, let's do it step by step. Now, this is just a different way of writing this down. It's a slightly different way of writing this down. It means exactly the same thing. Now I am going to multiply this by 1. 1 is known in algebra as the identity because if we multiply anything by 1, we are going to get the same result. Now, we are going to write 1 in a slightly different way. We are going to write 1 as d over c all over d over c. Now, it doesn't take a great imagination to show that this here is going to be the same as 1. So let's write this in a slightly different way. We can cancel this, and we're just left with a over b multiplied by d over c, which is the same as AD BC. Let's see, they're both the same, hence we have proved. Okay, it's not a strong proof, it's a weak one, but if you've understood that, you're doing well. Well done, and keep up your good work in maths.